Hey ladies and gentlemen, it's Professor Williams back with some more cool statistics stuff. This time it's how to solve binomial distributions with Minitab 16. I'm going to look at dragons this afternoon. Not all dragons are created equally. A recent survey by Knights of the Round Table Marketing found that despite popular opinion about dragons, they found that only 40% could fly, but 88% of them were able to breathe fire. To determine insurance premiums for the local kingdom, they sent brave knights out to sample the dragons. Based on their research and using Minitab to solve for binomial probabilities, I want you to tell me, if a sample of 16 dragons is taken, what is the probability that 9 or more dragons can fly? Of the sample of 16, what is the likelihood that between 3 and 7 can fly? In number 3, some of the dragons fly off, and now the sample has been reduced to just 13. What's the probability that all of the remaining dragons can breathe fire? And lastly, what's the probability that exactly 10 of the 13 dragons can breathe fire? Before you start Minitab, you really need to convert your binomial events into equations or break down the parts that represent the values for what you are solving, so that when you input your data into Minitab, you know exactly what you're solving. So what I've done is I've converted each one of these questions into the individual components of a binomial. I have the value for n for all 4, which are my sample sizes. 16 dragons in the first 2 questions, 13 dragons in the next 2 questions. Remember I told you that in the beginning that the probability that a dragon can fly is 40%. That's why p is equal to 0.40 for the first 2 questions. But remember, 88% of them can breathe fire. So that's why p in number 3 and 4 has been changed to 88%. Now, what about the number of successes we're looking for? In number 1, I want the probability that 9 or more. That means I want 9, 10, all the way up through 16. So I'm looking for the probability that x is greater than or equal to 9. Number 2, I want between 3 and 7. Well, between 3 and 7 is 4, 5, and 6. So you can see there that the probability of x being greater than 3 but less than 7 is the same thing as saying what is the probability that x equals 4, 5, and 6. In the third one, I wanted to know what's the probability all the remaining dragons can breathe fire? Well, I had a sample of 13. What's the probability that all 13 breathe fire? That means x equals 13. And then lastly, what's the probability that less than 10 of the 13 can breathe fire? You know from number 2 above, when I'm saying less than 10, then I want to know what's the probability that 9, 8, 7, 6, 5, 4, 3, 2, 1, 0 can breathe fire. So let's go ahead and open up Minitab and I'll show you how to put this stuff in. Alright, all I did was copy the question into my session window so that you could remember what I was solving for. I'm going to come up to Calc. I'm going to come down to Probability Distributions and I'm going to select Binomial, and it gives me this great dialog box. Because I want or more or less, I know that I have a cumulative probability. I insert the number of trials, which is 16, always n. Event probability is 0.40, which is the probability of success. Now I'm going to use an input constant. I want the probability that 9 or more dragons can fly. That means what I don't want is from 0 to 8. Because I don't want 0 to 8, I'm going to use 8 as my input constant and hit OK. What Minitab gives me is the probability that x is less than or equal to 8. Well, less than or equal to 8 is the same thing as saying 9 or more, because I know the probability of 0 through 16 equals 1. Since I know the probability of 0 through 16 equals 1, I know that the probability of 0 to 8 plus the probability of 9 through 16 has to equal 1. Because of the way that Minitab works, what this allows us to do is say the probability of 0 through 9 minus 1 will give me the probability that x is greater than or equal to 9. So I simply took 1 minus the probability of 0 through 8, and it gave me the probability of 9 or more as 0.14227, or approximately 14.23% of my sample of 16 dragons can fly. Let's see what we have next. Alright, I'm going to actually do this one is kind of two parts, because what I want to do is I want to isolate the probability that x equals 4, 5, or 6. So I'm going to come up here to Calc, I'm going to go back to Binomial Distributions, and I'm going to use the cumulative distribution function. We're still with n of 16, still a p equals 0.4, except this time I want to know what's the probability that it is really 4, 5, or 6. So I'm going to begin by calculating the probability of 6 or fewer. I'm going to say OK. And this is giving me the probability that x is less than or equal to 6. Except I don't want to go all the way down to 0. Remember, Minitab gives me that this 0.527 and change is the probability from 6 all the way down to 0. I don't want 3, 2, 1, or 0. So how do I eliminate that? I come back up to Calc, I come back up to Binomial Distributions, and now I say, give me the probability then that x is less than or equal to 3. Now what I know is that from 3 down is 0.0651. From 6 down is 0.0527. This number right here includes this number, because up here this probability of x equal to or less than 6 includes the probability that's less than or equal to 3. So I'm simply going to take the difference and I'm going to back out what I counted twice. What did I count twice? The probability that x is less than or equal to 3. So I'm going to take 0.527174 and I'm going to subtract out the probability of less than or equal to 3, and I'm going to come up with a probability of approximately 0.461 rounded. So when you are given one that requires that you solve less than or equal to, simply solve for your numbers in between. All right, let's go from there. All right, now we're dealing with our sample of 13 dragons, and I want the probability that all 13 of them can breathe fire. Based on that, in the binomial function in Minitab, I now no longer want a cumulative probability, I want an exact probability. When you're going to solve for the probability that x equals a single figure, use this probability radio button here. In this case, I now have 13 trials. The probability has gone to 0.88. What do I want to solve for? Probability that all 13 can breathe fire. So I'm going to enter that. I'm going to hit OK. And it's going to tell me that the probability that exactly 13 of them can breathe fire is 0.1897 and change. So approximately almost 19% of our 13 dragons can breathe fire. Last but not least, I asked you, what is the probability that less than 10 of the dragons can breathe fire? What we know is that if we're looking at a sample of 13, what's the probability that less than 10 can breathe fire? Well, it's the same thing as what is the probability that 9, 8, 7, 6, 5, 4, 3, 2, 1, or 0 can breathe fire? Well, what we know is that all of these probabilities will add up to 1. So what I'm going to do is I'm going to solve for the probability that less than or equal to 9 can breathe fire. So I'm going to say back to calc, back to probability distributions, back to binomial, and now I'm going back to a cumulative probability because I'm solving for more than one number. And now for my input constant, I want the number 9, because remember that input constant in Minitab is going to give me the probability that x is less than or equal to whatever number I enter as an input constant. In this case, I want my probabilities beginning with 9. So I'm going to put in 9, I'm going to hit OK, and it's going to tell me that the probability that x is less than or equal to 9, which are all those numbers listed up there, is 0.0608501. So I don't have much of a chance that less than 10 of them breathe fire.